this video, I'm going to take a train ride from Willaston station to Peel station to take a look at spot detection on my layout. Along the journey we will pass through Central Station Platform 3 before heading out through the mountain zone and arriving at Peel station. For spot detection to work on my layout, I used 5 cheap eBay infrared sensors. Here on this diagram you can see them as S1 to S6. I only use S1 to S5 on the single Arduino Nano. You can also see the pins that they are connected to. The sensors are buried between the sleepers of the track in the 3 locations as shown in the previous sketch. The data line from each sensor returns to this Nano. This Nano is connected to CMRI and JMRI using the RS485 UART adapter that I use. This is the software running on the Arduino Nano that you see. The first thing I do is include the CMRI.h and the servo.h. This allows me to run the servos and also use the CMRI protocol. I next give it the address that the node is going to use within JMRI. So in this case it's address 1. The next thing I do is define the turnout positions. So for me in this case, turnout closed is 70 degrees and turnout thrown is 108 degrees. I next need to define the signals. So I've got 3 2-aspect signals on the section. So these are assigned to pins 4 through to 9. You will also notice the JMRI address here. The next things we need to set up are the sensors, and these are here. So you can see these are connected to pins A0 through to A4. Now you might think that's strange, they've got the same JMRI address as 1002 to 1006. They are different because the signals are outputs, the sensors are inputs. I then define the turnout move speed. Now in this case I've set mine to 20. You could alter this. This is the number of milliseconds between each move. I then set up some variables, in this case int t1 state, int turnout 1 and an unsigned long turnout move delay. I then need to set up the CMRI function. So here in the brackets we've got CMRI address, which we set as 1. It's going to have 24 inputs and 48 outputs. This can be altered if you want, but I've left it alone. I then set up the servo for the library to work as servo turnout 1. I also declare 2 variables for the turnout position and turnout target. So these are turnout 1 closed position. This will become understood later in the code. The next section of code is the void setup. So here you can see I have put a delay in 2 seconds just to slow things down before moving on. This is not really necessary, but I've included it. I then set up the pin modes for the signals as outputs, and then set up the pin mode for the sensors as inputs using a pull-up built-in resistor. The next few lines of code here, they are used to turn the through approach green LED on and off with a 2-second delay. This section is used for the turnout 1, and we use the dot attach and we set it to pin 2 on the Arduino. I then use this line of code. On startup it will set the turnout to the closed position. Here you can see I've started the serial.begin and set the baud rate at 19,200. This is important to note that in JMRI, when you set the unit up, you need to also set them at the same baud rate. And that is the void setup complete. Next we'll move on to the void loop. In the void loop, the first thing you'll see is this line, which is jmri.process. This starts the communication between JMRI and the Arduino Nano. I then have this line, which is turnout1 equals CRMI.getBit0, and this is address 1001 in JMRI. We then have an if statement here. So if turnout1, which we've got this information from here, equals a 1, and the T1 state equals 0, the turnout1 target equals turnout1 thrown position, and then set the turnout1 state equals 1, which then I use a CMRI.setBit0 equals high. This I use for turnout feedback. The next if statement does the opposite. So if turnout1 equals 0 and turnout1 state equals 1, I want it to change the turnout position to closed. I then also change the state and also send feedback to JMRI. The next part of the loop, we have the digital write, and in this line we're setting the signal for the green approach. We basically read the CMRI get bit 1, and if this is on or off, it will either turn that LED on or off. You may notice I have the not here. I need to do this because the signals I use, I need to have it the opposite way around. So it's easier to swap it in the script on the Arduino rather than doing it in JMRI. These will all be looped through, one line after the other, and then it will move on to this section here. And here I am basically setting the bit in CMRI for bit 1 to not digital read pin A0. These are where my infrared sensors are connected. We then come to this if statement. And what this does is, if turnout1 position is not equal to turnout1 target, if millis is greater than the turnout move delay, turnout move delay equals millis plus turnout move speed. They then go on to if turnout1 position is less than turnout1 target position, turnout1 position plus plus. Now this will move the turnout at whatever the speed steps I used for this position. The next line, this one, if turnout1 position is greater than turnout1 target, we'll use the minus figure. And here, this is turnout1.write, turnout1 position. So this will loop until we reach the desired turnout position. I will link the code in the description of the video for my GitHub page where you can find the code, where you can have a look at it and mess with it.